Good to see you guys. Kind of like a first time at Spec, obviously. Oh, seriously? All right. Cool. Okay, so first time at Spec, obviously. Good to see you guys. I'm like usually up in SF, but I grew up in LA and I'm down here in LA like fairly often. Heard about Spec over at like SF, but never could make it to one of their things, so I guess I'm down here instead. Yeah. So I'm going to talk about an arm like I built with a couple of guys. It was a transhumeral prosthetic arm. A friend of a friend like had an amputation over there, and we were working on like, I was interested in biosignals at the time. A couple of guys were mechanical guys, so we were thinking like, why not just build an arm? See how well that goes. There was a couple parts. The main part was that, the main thing was that the whole thing was actuated by a single EMG sensor tied to a pectoral muscle. So that when you tense up, it grasps down in a way where like you'd be able to hold objects, but not too tensely. And the second part of this whole thing was that we had these fingertip sensors, barometer, accelerometer, encased in gel, where if you ran them across a surface, it'd pick up the vibrations and the pressure of that surface and replay them up on another part of your body. So you kind of could get a sensation of feeling. Pretty important. All right, so our main part was that we were just running everything off of a single motor, single pulley. Everything was kind of like hooked up so that your thumbs, your index finger, and your middle finger would get about a fourth of the force, and kind of cheated on the ring and the pinky. You'd get about an eighth of the force. So these three would close first, and these two would close up afterwards. So this is Adu, our bearded one, showing the thing. Yeah. Oh, how do I go to the next one? So like the EMG side was like, we built our own EMG sensor off of like in-amps and stuff. We got about like 88%, which is, in hindsight, not too bad. Could have been a lot better. The main stuff we kind of had like issues with was kind of covering, if you railed out your EMG, you kind of get like a good fast response. But for us, like the hard part was getting low response or like versus like noise. So you get like some, we tried to err towards like the side of caution, but like you'd also see some action like in normal.
Sorry, what's EMG?
Oh, electromyography. So basic biosignals. ECG is your heart signal. EMG is muscle signals. EEG is brain waves. The elbow we kind of cheated on. It's a ratcheting like hook. So you'd press into it, kick it to the right part, unratchet it, spring loaded. Fingertip sensors were pretty small. Barometer, accelerometer, the whole thing was just really meant to like fit on the fingertip. After you encase them in gel, in our case it was, I can't remember what it was anymore. It's something Flex, EcoFlex, I think. EcoFlex 10, I'm pretty sure. It kind of looked like that on the fingers. For actuators on the top, we used LRAs and servos. Servos were kind of like put up around where like essentially the arm remnant was, so they'd press up against it. And the whole thing kind of looked like that as the final assembly. Yeah. And unfortunately, I lost like all pictures of the final thing, so this is the best one I have with the electronics outside. Let's do questions. Where's the fish? Ah.
Two hands.
All right. Well, oh my God. I'm speaking to the fish's mouth, but I don't think. Can you guys hear me now? Oh, just the camera. Oh, hey, what's up, camera? Hey, Steven. So, on this arm, you said you're building it for a friend who lost an arm.
Friend of a friend. He had his own prosthetic,
okay.
but like it was just kind of like inspiration, right? Like,
Sure.
you get a bunch of like 22-year-olds who want to build something, but they don't really know what the heck to build. Yeah.
Reasonable.
Yeah.
So did he ever try it, or did you get a chance to test it on somebody who?
We did. The pros and cons. We kind of printed the arm like structure for his arm, so that actually did fit. Like everything was like on his dimensions. So we mirrored like his other arm. The downside is that we kind of did a lot of the EMG testing on ourselves, and we kind of found out that like body composition ends up playing a lot in this. Where we were sticking our like EMG sensors on ourselves, we had a lot less fat in between us and the muscle, whereas he had considerably more fat. So like it ended up being, by the time we got around to like testing with him, like we'd see that we'd end up getting like 88% because like noise floor was just a lot higher than what we thought it was, and the signal was just a lot lower.
So
yeah,
if you were to do it again, how do you think you would change it to fix that?
I cannot hear you.
Sorry. I'm talking to the microphone though. No. If you were to do it again, how would you try and like fix that? Like what would your strategy be to go after that problem?
I mean, it's honestly just getting like a larger data set, right? So we were kind of dumb, and we honestly just tested on like a set of like 5 of us, and then used that as our data set. We honestly should have expanded out, gotten more people, just collected more data off of like other people. Like, all right, Flex, like, you know, just bring a bunch of pizzas out, come in, have some pizza. By the way, we're gonna hook you up to like this like test system and have you do a few things. Yeah.
Pizza's always a good answer. Oh, here's the fish.
So you said the fingertips could read like texture in a variety of ways and then play it back to somewhere. Can you tell me more about that? Like what is it actually measuring, and then how is the playback happening?
So the EcoFlex we kind of picked out was like pretty close to like the consistency of like what your finger actually was, and we ADXL like 345 accelerometer and a barometer in there. The barometer is pressure, the accelerometer is just kind of like acceleration of that. So the nice thing is that the accelerometer like wasn't quite perfect. It wouldn't catch like anything basically high like resolution, but if you were running across something and you'd hit like a bump, like it'd catch that. And the barometer was actually barometer actually worked pretty well. More pressure, more that. Barometer to servo in terms of like playback was trickier, right? Because it's kind of like another issue with like body composition. You can move your servo to like the same position over again, but if it was slightly offset or your arm's in a slightly different position, you're kind of pushing a little harder or a little less onto the person. So like probably some sort of feedback on that side would have been better. The other side was like vibration feedback was surprisingly easy with like LRAs. As long as we like didn't hit the notch on the LRA, we were getting a pretty good response off of that. Yeah.
Thank you.
3 quick questions. What chipset are you using?
Oh, you guys are gonna kill me on this.
Like,
All right.
I mean, it's like, what did you kind of base everything off of? Like, how much is the BOM to build one of these, and is everything open source?
BOM was 700. I think we lost everything. We gotta find it. We wanted to make it open source, and then we just
Is he wearing the arm?
No. He had like this very nice medical arm that insurance paid for.
Oh.
Yeah, I mean, I'd wear that arm too, not this one. BOM was around 700, mostly because we printed it out. The main problem we kind of ran into is that our pulley system, our fingers were definitely like rated up to like 50 pounds in terms of like holding stuff on. I'm not exactly sure our steel wire could like hold past that, like consistently, like for long periods of time. So like that's kind of something we ran into there. Chipset we were using for all you 2-bit guys was an Edison, because I was working on the team. So like, yeah, like basically there were like maybe like 10 people who actually knew how to use an Edison, and I was like one of them. What's up? We were actually thinking about that. Holding weight is hard as hell. Yeah.
So is it all open source?
No, like I've got some of the software. Someone else is like the fingers are open source somewhere, because that actually was somewhat useful. But the rest of it was like kind of trash, or like we weren't exactly happy with it. Yeah.
Fair enough.
Yeah. Cool. Cool.